welcome to the video on integration by parts. Really fun method here for integration. So we haven't talked too much about integration techniques. A lot of things we've talked about so far in all my videos have been, hey, does it match this formula? Or we could use a U sub and then match to a formula. So we're going to start to tackle some integration problems where they're a lot more complex. Okay, so the first method that we can use to integrate is something called integration by parts. There's actually a couple different ways to do integration by parts. We're going to use the tabular method. Okay, so first way you could do it is just memorize this handy dandy little formula here. Is dv is equal to uv minus integral of v du. So that's one way you could do it, just memorizing it. So, or the other way is use the tabular method. And what you're going to do here is you pick your u and you pick your dv. And your u is something that's easy to take the derivative of. So you don't ever want to pick anything that's tough. And your dv needs to be something that's easy to take the integral of. Okay? So this is where we get to this little bit of a Liete type of deal here. If the integrand is a product of two functions from the categories listed below, let u be the function whose category occurs earlier in the list, and let dv be the rest. So if you have a log, you want it to be a log. Okay, you want your u value to be a log. And inverse trig would be the next one, and then algebraic, and then trig, and then exponential. So it kind of goes through this list right here, because a lot of times we get these problems, and I'll just show you real quick, where you're just like picking this one right here, like, oh my gosh, which one do I pick? Do I pick e to the 2x, or do I pick sine of x dx? And all you would do is you would just look at this right here, the Liete, the log, inverse, algebraic, trig, exponential. See how it spells out, I-L-I-A-T-E. So for that example I just showed you right here, you have trig and you have exponential. Okay, so you want your u to be, well, no log, no inverse, no algebraic. You want your u to be the trig. So that's just kind of how we use that as just a nice little friendly reminder of what you can do. Okay, so we're going to talk about the tabular method real quick. And it's highlighted right here is the table can be continued using the same pattern. You're going to circle the entities that are multiplied in front of the integral, and the last two entities are multiplied inside of the integral, and the signs to the left indicate whether the entries are added or subtracted. So we're going to do three things. The first one will be easy. We just do a plus minus plus minus. Second one, we just keep taking the derivative of. And then the third, we just keep taking the integral of it. So what's going to happen is you pick a u, pick a dv, and then you just do the first part of the table. Your table should always start with 2. Okay, so you're going to get your u du, your dv v, and you would just circle the u times v. You would multiply those two, and then you would think, can I find the integral of the next part of my table? And if you can, you're done, and you just write it out into this formula right here, and you just finish the problem using simple integration. If you can't, then you just keep going, and you're going to keep going and going until one of two things happens. Either you get something easy enough to take the integral of, or if it starts to repeat itself, then, well, we'll get to that when we get to that. Also, take note of these handy dandy inverse trig formulas that will be coming up, I believe, not in this video, but the next one. But the reason this is highlighted because this can come into play into your daily work. All right. And then also this does relate to this inverse trig stuff as well. All right, so let's go through it. So first problem here, we have x sine of x dx. So I'm going to do my little tabular method here. So a plus and the minus, and I just in case I need to go any further, it's there. Okay, so my u, what's easy to take the derivative of? Okay. If you use Liete, the algebraic comes before the trig, so we do that. And then my sine of x dx goes here. So I'm just going to just leave it as sine of x. Okay. So, and also, if you take the integral of x, you're just going to keep getting nasty things with fractions. So I think it's a little bit easier set up this way. So what's the derivative of x? And that would be 1. what is the antiderivative, again, second column's antiderivative of sine of x? It's going to be negative cosine. Okay? So this is how this works, is you would do x times negative cosine of x minus the integral of 1 times negative cosine of x dx. Okay? Just kind of walking you through how this process works. And I'll talk about why I stopped where I did in just a moment and how to find some of the stuff out. So from here, I'm just going to do some distribution. I'm going to get negative x cosine of x. That's going to turn to a plus integral of cosine of x dx. And the integral of cosine x dx is pretty simple, which is going to be a positive sign. So it's going to be sine of x. And then don't forget your constant of integration. So this is your answer. So now that I did the problem, I'm going to walk through the steps with you. So we just had x dx. Oh boy, the lights just turned on me. Better turn those back on in a second. I have x dx. Sorry, I got thrown off by the lights being turned off on me. So I have x times sine of x dx. There's no way to integrate that. If you were to use u sub, you'd fall into some issues. Okay, so that's how I know I'm going to try to use integration by parts. So by doing that, I have my x as my u, my sine of x as my dv, and then I take the derivative of x, take the antiderivative of sine of x, and I left here. Now, I would keep going, except I know that if I read this across from left to right on the bottom, well, okay, I can integrate 1 times negative cosine. So that's how I knew to stop. And then you would just do the diagonals minus, and then you would just integrate from here, and then you would get it. All right, so I'm going to turn the lights back on. Why don't you start? See if you can set up the next one. Which one comes first, the x squared or the e to the x? All right, so what'd you pick? What's that? You picked x squared to come before e to the x. I agree, because algebraic comes before the exponential. So the derivative here is going to be 2x. Antiderivative e to the x is just going to be e to the x. Okay. So is it easy to take the integral of 2x e to the x? No. So I'm going to make another row and then alternate signs here. This is plus. Derivative is going to be 2. Antiderivative is going to be e to the x. Can you take the antiderivative of 2 e to the x? Sure can. And you also know that you're done too, because you take the derivative again, you're going to get a bunch of zeros. So that's another way to know that we'd be done. So here we go. I'm going to do circle my diagonals. So I'm going to have x squared e to the x. Okay. Minus 2x e to the x plus my last one, integral 2 e to the x dx. Okay, so this is taking my tabular method, putting it out onto paper right there, and now we can go ahead and really just taking the antiderivative of this, 2 e to the x. I'm just copying everything else down. Antiderivative is just going to be 2 e to the x, and then don't forget our constant there, and that's it. It's not so bad. I have seen, actually, I lived through college classes where we have a problem like this, and it just takes a long time to do. I'm a huge fan of the tabular method. It was brought to me a couple of years ago, and love it. Makes life so much easier. So again, this problem, you can't integrate it. You have to use integration by parts because we just don't have any other methods to use. U sub ain't going to work and ain't going to knock any of those out, so we're forced to use integration by parts. All right. So I said to you there's two ways to know when to finish your tabular method, right? The first way is if you know that you have the bottom line, if you can integrate that, then you're done. The second one is if it repeats itself, which is going to end up happening here. Okay, if you keep getting the table to repeat itself over and over and over and over again, well then we're just going to use some very, very simple algebra. Okay, so I'm going to go ahead and do that right here. So let's use the tabular method. I'll stick with purple. So what goes first? And I talked about this already. The trig goes first or the exponential goes first? The trig does. So plus minus. So I'm going to have sine of x. Over here, I'm going to have e to the 2x. Now, we can find the antiderivative of that. Okay, it's just a baby u sub. So I don't think we'll have any problems finding the antiderivative of e to the 2x. So derivative of sine of x is going to be cosine of x. Antiderivative of that is going to be 1/2 e to the 2x. You could do a little bit of a baby u sub there to figure that one out. Okay, I cannot integrate that. So I'm going to keep going. So plus antiderivative of cosine is going to be negative sine of x. And then derivative of cosine is negative sine of x. Antiderivative of 1/2 e to the 2x is going to be 1/4 e to the 2x. And now this is where I see a repetition here. All right, so this right here is going to appear right here. So now if I keep doing this table, I'm going to end up getting pretty much the same thing where this number right here will just keep growing and growing and growing. So I'm pretty much done at this point. Now, this one has a little bit of a different technique. What you're going to do is you're going to rewrite this out because you're going to have to manipulate it a little bit. And you'll see what I mean here in a second. So integral from e to the 2x times sine of x dx. That's going to equal. And let's go ahead and write this thing out. So I'll circle this in the blue. So we're going to have sine of x, so 1/2, let's put that in front, sine of x times e to the 2x, okay, minus let's put the 1/4 out in front, cosine of x times e to the 2x. And then I'm going to get plus this. So plus my integral of negative sine of x times 1/4 e to the 2x dx. So if you notice right here that these things are going to be very similar. So let's just clean this up a little bit and you'll see what is happening. So we're going to get e to the 2x sine of x dx equals, just a little bit of cleanup. I'm going to rearrange some of this stuff so it just looks nicer. So I'm going to get e to the 2x all over 2 sine of x minus e to the 2x over 4 cosine of x. That just looks nicer. Distribute that all the way out in front. Minus 1/4 integral of e to the 2x sine of x dx. Okay. Now look at this. These are the same things over here. So now we can treat this like it's an algebra 1 problem at this point. All we got to do is just add both sides. The 1/4 e to the 2x sine of x dx to both sides. And that's going to give me 5/4 e to the 2x sine of x dx. I'm just trying to see how I wrote it before. E to the 2x all over 2 sine of x minus e to the 2x over 4 cosine of x. And now all we're going to do is just divide both sides by 5/4, and we'll get our final answer of e to the 2x sine of x dx is equal to, multiply that by 4/5, Right, yep. Okay, and I'm just going to kind of just leave it like this. I'm not going to clean it up too much. I don't want to take too much of your time. It's not so important because you could take out a GCF of a 2, clean it up a little bit, or you can distribute that in, clean it up a little bit, either way. Minus e to the 2x over 4 cosine of x. And then just don't forget your plus c at the very, very end. That one kind of can get forgotten pretty easily. Just because since we're figuring out that the final answer is right here, just add a plus c. So again, this is the more annoying of the ways, but if you have a repeat, you can go ahead and set it up like this, and then you can solve for the original problem. Okay. Hey, last one. Won't take too long on this one. It's not so long of a problem anyway. So we have integral from 1 to 2 of ln of x dx. So how this is going to work is as I do each step, I'm going to evaluate, like for instance right here, I have to evaluate each one of these as I go through. Obviously, you don't need a constant of integration here. So I'll kind of just stick that to the end. So for this one, there's no formula, believe it or not, for ln of x dx. So we need to go ahead and integrate it. So we're going to let, again, using Liete, L stands for log. That's the first thing. So if you ever see an ln, that has to be the first thing we do. So we're going to have ln of x times what? Nothing. That's going to be just a 1. Okay, so it's just a constant 1. Derivative of ln of x is 1 over x. Antiderivative of x, or sorry, of 1 is going to be x. And look, if I multiply 1 over x times x, I can take the antiderivative of that, and it'll be totally cool. So I'm going to be left with x ln of x. So this is going to be x ln of x. I'm going to evaluate that from 1 to 2 minus the integral from 1 to 2 of x times 1 over x is just nothing. And turn it to dx. Okay. I'll just wait to evaluate that in a second. So I'm going to get x ln of x minus x. And actually, I'm going to end up evaluating all of this from 2 to 1. So I just kind of waited. I have it there because technically, yeah, we are evaluating from 1 to 2. I'm just kind of waiting for it to come to the end here. Now I'm going to plug in my 1 and my 2. So I'm going to get 2 ln of 2 minus 2 minus 1 ln of 1 minus 1. Ln of 1 is 0. Okay, so I'm going to end up with 2 ln of 2 minus 2. This is going to be a negative 1, so minus a negative 1 is plus 1, which is going to give me 2 ln of 2 minus 1, which is my final answer. You can clean it up a little bit if you know that that's really going to be ln of 2 squared, right? You can put that on top. So ln of 4 minus 1 would probably be the answer that AP has for this one. All right, and there you go. You dip your toe into a little bit of the BC world with integration by parts.